Now let's learn about R square. So R square is similar to the accuracy. So we are using this R square as an evaluation matrix in order to evaluate the model, that is linear regression model. So in the case of linear regression model, if you want to evaluate whether this linear regression model worked perfectly or not, whether the line that is created by the linear regression model fits better for the data or not. So in order to visualize, in order to see that, we use this R square. So let's see, R square is similar to the accuracy and it is an evaluation matrix. That means it is going to check whether our model is just running perfectly or not. So it is same like accuracy. So now let's take an example, our quite example. I'll just take some example over here in order to just compute this R square. So for now, what I'm going to do is I'm going to say here is a mouse size. So here we have a mouse size and here we have a mouse weight. So here we have a mouse weight. So we can clearly see this is a mouse size. So as the size increases, the mouse weight also increases. So that means it is a linearly correlated. So I have a data over here. So I'll just say these are my data. I have 4 data over here. So these are my data. So now we applied linear regression to this model and our linear regression gave something like this. So let's say our model gave this. This is a linear regression model. So linear regression, after just employing that y equal to mx plus c equation, we get this linear regression model, and with this linear regression model now we are going to calculate R square. So the formula for the R square is to calculate the variance. So we have to calculate the variance in order to calculate the R square. So the formula for the R square is, let me just write here first, variance of mean minus, let's say variance of mean minus variance of fit, that is fit by the line. So variance of fit is a fit by the line divided by variance of mean. So this is our basic formula. Let's check now what does this represent. Now let's see how to calculate this variance of mean first. So variance of mean is, first of all, we get these points. These are all the data points that we have. So first of all, map this over here. So that means get the y value of each of these values. So just get the y values, just map this to the mouse weight, or basically map this to the y. So this is our y value. Now just see this point now, each and every point, and now calculate the average of this point. Just calculate the average, and let me just guess the average will be somewhere here. So average will be somewhere here. Now calculate the distance between this value, this y of value, to the average. So that means just calculate the distance between y minus y bar, this y minus y bar, and compute this square, means compute the variance. So variance formula is nothing but sum of squared error divided by n. And in this case, whenever we do something like divide by n, the n cancels out over here. So this n does not play important role, because if you just do somewhere there, yes, sum of squared error of mean minus divided by n, all have this n, and minus variance also have this sum of squared error of fit divided by n, and even here at down we have sum of squared error of mean divided by n. So this, all of this n cancels out, and our formula becomes sum of squared error of mean minus sum of squared error of fit divided by sum of square error of mean. So this will be our formula. So this you can take a LCM from here, just a LCM, and this n and upper m will cancel out, and this formula will be our output R square. So now firstly we have to compute this SSE mean. So SSE mean is, first of all, map all to the y-axis and calculate the mean. So the mean here will be y bar, and just calculate the distance. This is the distance. So sum of squared error is just a distance from each of these points. Like consider this y1, consider this y2, y3 and y4 for 4 points, and calculate this for all from I equal 1 to 4. And this task here is nothing but sum of square error of mean. So this is the sum of square error of mean. So now let's do same task for the sum of square of fit. Fit is basically this line. So line is the fit. Now we have to calculate the distance between the observed and the predicted by our line. So this distance, these errors. So these errors should be calculated. So for that, what we need to do? We need to do something like this. First, we need to calculate, just take this y, which is observed value of y, minus predicted value by the model, which is this line, this point and error, and just square all of this and take a summation for each of these points, which is I equal 1 to n. And you compute this value, and this is for sum of square error of fit, and divide by same of that sum of square of mean. Just divide that value, then it will become r square. So now let's take this example and let me show you. Now again, what if, let's say what if r square value comes, that is 0.6. Let's see, the r square value ranges from 0 to 1 first of all. So if you have r square value that is beyond this limit, then your r square value calculation is wrong. It should be inside this 0 to 1. So what if I got the r square value 0.6? What does this imply? So this means the mouse size, this mouse size x, this x has 60% of importance. So x will predict 60% of data accurately of y. So that means this x, mouse size, which is our input, y is our output. So that means having 60% is same as accuracy. Like saying x, the value of x can predict 60% accurately the value of y. So that is 0.6. What if 0.9? So that means our x, mouse size, can predict 90% correctly the value of y. So that means the importance of x, the importance of x to predict the y. So as r square value changes, the importance also changes. Let's see the quite example over here, how this r square is very much important to deal with. So let's take example. I have this value, and our model is this model, linear regression model, and let's take example that data set, each and every data set that is predicted by our model is accurate. So this you can see this blue, this is dot, this blue dot is that is observed value, and this observed value is just lying inside this model. That means the observed and model are equal. The model predicted for each of these data points accurate value. So the error is 0 here. So let's calculate r square for this. So to calculate the r square, what we do is, first of all, we calculate the variance. So first of all, we map all of these points right here in the y-axis, all of these points, and we calculate for these 3 points, we calculate the mean. So let's say the mean comes over here, and now calculate the distance. So first this distance, and second this distance should be calculated, and third this distance. And this distance, let's say this distance came as 15. I'll just randomly choose this. This distance came as 15, which is, so let me take the formula again. Variance of mean came as 15. Now our formula is variance of mean minus variance of fit divided by variance of mean. So this is our formula. So now let's calculate variance of fit, because we calculate variance of mean, which came out to be 15. Let's calculate the variance of fit. Fit is nothing but this line. So now let's calculate the sum of squared error between this observed and predicted value. So observed value minus predicted value for each of these. So for this first data point, this is the first data point. Similarly, for second data point, O2 minus P2. This is for second data points. And third data points, it is O3 minus P3. This is our sum of squared error. And if I do sum of squared error divided by n, number of data points, in this case divide by 3, then it is a variance. Now the observed value and predicted value is exactly the same by the model. So that means the first is 0, second is also 0 because second point is also in the predicted line, and third is also 0. So here the variance is 0, variance of fit is 0. Now let's calculate this R square. So R square value will be variance of mean. This variance of mean is considered 15 minus, now variance of fit came as 0, divided by again the variance of mean, which is again 15. So 15 divided by 15 is 1, which is 100% accuracy, which we can see directly from here, because our model is perfectly, that is predicting this observed value correctly, all of these observed values. So that is 100% accuracy. So R square is basically giving the accuracy, the measure of how much importance does the X make to predict the value of Y. So that is R square, and in order to check the accuracy we use this R square for the regression model. That is all in this lecture.